back to the extreme value theorem. If both of the conditions in the hypothesis of the extreme value theorem are not met, specifically, if the function is not going to be, it has to be continuous it has to be a closed interval on each end of x values on which it is continuous. If those two criterions are not met, then the function is not required to have an absolute extrema. Although it may have it, we have no guarantee that it will. So let's see some examples where we don't meet the two criterion. First, we have an example where the function is continuous on the open at 0, closed at 1. So this is not a closed interval of x values. So we expect to see a problem here. Let's graph this function. 0, 1. Okay, we have an asymptote at 1. We have an open circle at 0 because it's not even defined there. And it's asymptotic at 1. Here's our function. This implies that there is no absolute extrema. You can see there's no absolute maximum because there's an open circle at the x equals 0, and there's no minimum. Our next function, it violates one of the two conditions in a different way. It's defined on a closed interval, a to b, but it's not continuous on that interval. So we have a function that goes from 0, and then there's going to be a 1 and a 2 involved here. Now it's solid point here at 0, but it's an open circle, and it's a solid point at 2, but then and a solid point above the open circle at 1. So even though it's defined on the entire interval from 0 to 2, we do have an absolute maximum at x equals 2, but we don't have an absolute minimum. We had no guarantee there would be both of them here because they didn't meet both of the criterions of the extreme value theorem. So as you see, a discontinuous function could have a max or a min, as it did in this example, the second part B, and it might in your homework, but they are not required to give you a max or a min since they don't meet the conditions of the extreme value theorem. Okay, so I'm thinking, you'd think from these sketches that a max or a min point on the graph is always going to have a horizontal tangent, that there's going to be a relationship between the two. Just think about these and the other pictures that we've been discussing. You just figure, wow, I guess there's always going to be a horizontal tangent. Well, I mean, I'm thinking a horizontal tangent, of course, it means f prime of c is equal to 0. But is this always going to be true? That we're going to get a max or a min, we'll be able to find horizontal tangents or relationship? I mean, can we find extreme values on the graph, the max or the min? Can we find them by simply finding the x values c where f prime of c is equal to 0? Well, look back at the graphs we've been doing. A lot of them look like that. Well, the answer to that question is no. That's not good enough. There might be something else involved, and that's what we're going to discuss next.